Welcome back everyone. Next we are going to discuss about different operators we have in Python. And in this particular video, we are going to learn about arithmetic operators in Python. Arithmetic operators are pretty simple. You might already know about them in general, but there are a few things we need to be careful about while using these operators in Python. We are going to learn about all of them in this video. Now we have these 7 arithmetic operators in Python: addition, subtraction, multiplication, and when it comes to division, we have two types of division. First one is floor division, represented by double slash, and then we have floating point division, which is represented with this single slash. And then we have modulus operator, which is represented with this percentage symbol. This is also called remainder. And finally, we have a special operator called power or exponent, which is represented by double star. So here a double star b is nothing but a raised to the power b. Generally we call this a as base and we call this b as exponent or power. Now these arithmetic operators, they work only between numerical data types, which means we can use them only with integers or floats. We also have complex data type in Python, but we rarely use complex numbers in real-time applications. So we generally use these arithmetic operators with integers and floats. If you take this expression a plus b, plus is called operator, which is addition operator, and a and b are called operands. So these operands a and b can be of type either integer or float. And all these operators are called binary operators because they work between two operands. Now these operands a and b can be either integers or floats. Both of them could be integers, both of them could be floats, or one of them could be integer, the other one could be float. Now what will be the data type of the result of the expression? Will it be integer or will it be float? Let's try to understand. Let's keep this floating point division operator aside for a while, and if you take all the remaining 6 arithmetic operators, the result of the expression is float if any of a comma b is float, else result is int. Which means if both operands a and b are integers, then the result will be int. But if at least one of them is float, your result will be float. Now when it comes to this floating point division, which is represented with this single slash, the result is always float, which means even if both a and b are integers, the result will always be float. But in case of all the remaining 6 arithmetic operators, the result will be float if at least one of them is float. Now there is one exception we need to understand about this exponentiation operator. So if at least one of these a or b is float, obviously the result will be float as per this rule, right? But there is one more case where the result will be float. For example, if you take this a double star b, which is also called a power b, the result will be float if exponent is negative, which means if b is negative. If one of a or b is float, obviously the result will be float as per this rule. But even if a and b are integers, if b is negative, then the result will be float. Let's see this example to understand why it works this way. So if you take this example, we have 4 double star minus 2. So here the exponent or power is negative, minus 2 in this case. So this is equivalent to 4 power minus 2. Now when we have a negative power like 4 power minus 2, this is equivalent to reciprocal of 4 power 2, right? So 4 power minus 2 is equivalent to 1 by 4 square, which is 1 by 16. Now 1 by something is always a fraction, right? So this will always result in a decimal point number, which is also called floating point number. This 1 by 16 is equal to 0.0625 if I am not wrong. So 4 power minus 2 will evaluate to 0.0625. So that is why if the exponent is negative, your result will always be a floating point number. We are going to discuss a lot of examples, then this concept will be much more clear to you. Now let's see some examples on usage of these operators. First we have addition, subtraction and multiplication. These are very simple and straightforward, but only thing we have to be careful about is when you have a floating point value in your expression, your result will be float. For example, if you take these two examples, Here we have 2 plus 5. Here we have 2.0 plus 5. In this case, we got an integer 7. In this case, we got 7.0 because one of the values is float. Sometimes when we have 0 in the decimal part, we tend to ignore this dot 0 and we simply write 7 sometimes. But when it comes to Python, 7 and 7.0 are not equal. This is an integer object. This is a float object. So always remember, if in your expression, if you have a float value, your final result will be a float value. Now if you take this example, here we have 2 plus 5.2. When you add, it will be 7.2. In this case, it is obvious because we have 0.2 in this case. But when you have dot 0, that's when you have to be careful about. So don't ignore dot 0. All right. Now if you take this example, here we have 3 operands, right? We have 7, 2 and 3.0. Till now we have seen only expressions where we have 2 operands. But in general, we can have expressions with more than 2 operands as well. But we know that all these arithmetic operators, they are binary operators, which means each operator, it works only between 2 operands. So while evaluating these kind of expressions where we can have more than 2 operands, Python first groups the operands based on operator precedence and associativity. For example, this expression will be grouped as 7 minus 2 minus 3.0. Don't worry about why it is grouped this way for now. We are going to learn about it when we discuss operator precedence and associativity. I just want to introduce you to an example where we can have more than 2 operands in an expression. Now once this is grouped this way, it will evaluate the expression. So this minus is applied between 7 and 2. So 7 minus 2 will evaluate to a value 5, right? So this will evaluate to 5. Now this minus is applied between 5 and 3.0. So 5 minus 3.0 will be 2.0. As 3.0 is float, your final result will also be a float. So one thing we can conclude here is, even if you have a very big expression, if one of the operands is float, eventually your overall result will also be a float. All right. And sometimes in an expression, we can have different operators as well, like 7 plus 2 star 3.0. We can have these kind of expressions as well. But to understand how this expression is evaluated, we need to know operator precedence and associativity. We will be discussing that in future. Don't worry about it for now. Just keep in mind that if in an expression, if one of the operands is float, your overall result will be float. Now let's see the last 2 examples. Here we have 5 star 2 and here we have 5 star 2.0. So here we have at least one float value. So your result will be float 10.0. In this case, we have both integers. So the result will be an integer 10. Now let's write some code to verify all these examples. Now in this project, let's create a Python file with the name Arithmetic Operators. But we can do something here. As we are going to create a lot of Python files, we can group these files into multiple folders. For example, we can create a folder called operators and we can keep all the files related to different operators in this folder. This will help us organize the large number of files in a project in a better way. So first let's create a folder. So you can right click on this project folder and you can select new, and here you can select directory, which is also nothing but folder. Now you can give a name operators. So inside this, we can add all the Python files related to different operators. So let's create a Python file inside this folder. So you can right click on this folder, right click, select new, and you can select Python file, and let's give a name Arithmetic Operators. All right. So our Python file is created inside this folder called operators. All right. Now let me add all the examples we discussed. So I've pre-written all these examples because if I write all these examples one by one right now, it will unnecessarily take a lot of time. Anyway, you can access the code snippet directly from the website. So I've put a comment here indicating that these are examples of addition, subtraction, multiplication. And you can see that I also added a print function where I am printing this description to the console. And the advantage of this is when we run this program, when we execute this program, So it will first print this description below which all these outputs will be printed. As we are going to write a lot of examples, keeping these kind of descriptive messages will help us easily locate our outputs. Alright, now if you run this program, right click, run arithmetic operators. So this is the output we got. So first this description is printed under which you will have all these outputs. So you can verify that we got the same outputs as we discussed. The important point you need to notice here is when we have at least one float value in the expression, the result is also float. Alright. Now one very important point we need to understand is float is not always precise, which means when we use floating point values in our expression, we may or may not get the exact result. Now let's take these two examples to understand about this. So here we have an expression 9.2 minus 1.2. So what is the expected output? We expect the value to be 8.0, right? Similarly, if you take this expression, here we have 2.2 multiplied with 6. So what is the expected result? We expect the value to be 13.2. Now let's run this program and see what actually happens. So this is the output we got. So here 9.2 minus 1.2, we expected the value to be 8.0. But we got something very close to 8.0 but not exact value. We got 7.999999 so on. Similarly, in this expression, we expected the value to be 13.2, but we got a value like 13.200001. So the actual outputs are very close to the expected outputs, but still they are not exact values. But in the previous examples, we got the exact result, right? So in all these examples, we got the exact values. So we may or may not get the exact result. So whenever our expressions involve floating point operations, the result might not always be precise. For example, in this expression, we expected the value to be 8.0, but we got something very close to 8.0. The difference is only 0.00001, but still it is not exact. Similarly, in this example, we expected the value to be 13.2, but we got a value which is extremely close to 13.2, which is 13.200001. And in the previous examples, we got the exact values, right? So it's not practically possible to remember when we will get exact value and when we will not. And this happens due to something called IEEE floating point representation Python uses. Let's not get into the details of it, that will be out of scope. The only thing we need to keep in our mind is floating point operations might not always give us exact results. But there are a few cases in which we want precise floating point operations. For example, currency conversion. Let's say we want to convert from dollars to pounds or dollars to Indian rupees. Another example can be when we deal with stock market prices. In such scenarios, we want to have precise operations. So what can we do in that case? In such cases where we want precise floating point operations, we can use decimal module in Python. A module is nothing but a pre-written Python file which will have some functions and classes using which we can perform various operations. We will be discussing about modules concept in future videos, but for now just keep in mind that floating point operations are not always precise, and whenever we want precise operations, we can use this decimal module. Now let's move on to the next operator, which is floating point division operator, represented with this single slash. Now the important point about floating point division in Python is result will always be float. If you take these two examples, here we have 10 by 2, both are integers. Here we have 10 by 2.0. One of the operands is float. But in both the cases, we can see the result is float. In general, when we solve math problems, when we have 10 by 2, as 2 divides 10 perfectly, so we will write the value as 5. But in Python, the result will always be a floating point value. In the next example, we have 3 by 2. The result will be 1.5. In this case, the result is kind of obvious because here denominator does not divide the numerator perfectly. So you will obviously get a decimal point number. But in cases like this where the denominator perfectly divides the numerator, That's when we can get confused and think that the result will be integer. But always remember, in Python, this slash is nothing but floating point division, which means the result will always be float. Now let's see the last example, 10 by 3. Now this 10 by 3 is a non-terminating fraction, right? If you divide 10 by 3, you will always get a remainder of 1. So you will continue infinitely, right? So 3.3333 so on. It will never end. And Python can at max represent 15 to 17 digits when it comes to floating point numbers. Sometimes it can be 15 digits, sometimes it can be 16 or 17 digits as well. And when you say number of digits, it is including this integer part as well. So including integer part and decimal part, at max it can represent 15 to 17 digits. So when we have these kind of non-terminating decimal point numbers, we might get an approximate output value in range of 15 to 17 digits. Now I have added all those examples here. So let's run this program. Right click, run. And as you can see, using this description, we can easily locate the output, right? So the output is under this description. And as we discussed in all these examples, we got a floating point value. Now, if you see this last example, 10 by 3, this is non-terminating fraction, right? We get 3.3333 so on infinitely. So Python will try to give you a value which is approximately equal to that value. And if you count the number of digits, in this case, we got 17 digits. Now let's also see what we will get when we have 100 by 3 and 1000 by 3. What will be the value of 100 by 3? It is 33.3333 so on, right? Non-terminating decimal. 1000 by 3 is 333.3333 so on. Now let's see what exactly Python gives. So let's run this program. So in case of 100 by 3, again if you count, we got 33 point something. So if you count, we got 17 digits. But in case of 1000 by 3, if you see, we got only 16 digits. So we can get anything in range of 15 to 17 digits. And when you say count, it is including both integer part and decimal part. In total, it can only represent 15 to 17 digits. Next, we have floor division, which is represented with this double slash operator. Now, if you take this example, 10 floor divided by 3, floor division is nothing but floor of 10 by 3. So here this 10 by 3 is nothing but floating point division. 10 by 3 is nothing but 3.3333 so on, right? So to this value, floor is applied. Now what is this floor operation? Floor of x is nothing but the greatest integer which is less than or equal to x. What is the greatest integer which is less than or equal to 3.33333? It is integer 3, right? If you take this number scale, so 3.3333 will be somewhere between 3 and 4. So what is the greatest integer less than 3.333? It is integer 3. So that's why floor division of 10 by 3 will give you 3. And that's why we also call floating point division as exact division and floor division as integer division. Because floating point division will try to give you the exact value. For example, for 10 by 3, it will try to give you 3.3333 so on. But when it comes to floor division, it will try to give you a floor value, which will be an integer. Now, if you take next example, minus 10 floor divided by 3, this is equal to floor of minus 10 by 3. So this is floating point division, right? So minus 10 by 3 is minus 3.3333 so on. Now what is the floor of minus 3.333? It is minus 4. It's not minus 3. Because minus 3 is greater than minus 3.333, right? Floor is nothing but the greatest integer which is less than this value, which will be minus 4. Now let's see the next example, 10 floor divided by 2, which is nothing but floor of 10 by 2. So floating point division of 10 by 2 is 5.0. So what is the floor of it? What is the greatest integer which is less than or equal to 5.0? It is 5, right? 5 is equal to 5.0 quantitatively. So this will result in 5. Now let's see these two interesting examples. In these two expressions, we have at least one of the operands as float. If you take this example, If you simply apply floor to 10.0 by 2, 10.0 by 2 will be 5.0, and when you apply floor, this will give you integer value 5, isn't it? But we know that when any of the operands is float, our result should also be float. So the result should be 5.0 and not integer 5. So in such cases where we have at least one of the operands as float, we can write float division as float of floor of 10.0 by 2. So 10.0 by 2 will give you 5.0, floor of which will give you 5, and the result will be float of this 5, which will be 5.0. Similarly, if you take the next example, here we have 10 float divided by 3.0. So the result will be float of floor of 10 by 3.0. 10 by 3.0 will give you 3.3333 so on, to which if you apply floor, it will be integer 3, and the final answer will be float of 3. So you'll get 3.0. Now should we always follow this step-by-step process to find the value of float division? Actually, there is a shortcut we can use when we have float division between two integers. For example, let's say we have 15 float divided by 2. So the result of this is nothing but the quotient of this division. We all might have done this kind of division in our school. So if you want to divide 15 with 2, now 2 can divide 15 7 times completely, right? So this will be 14 and 1 will be the remainder. So 7 is the quotient and 1 is the remainder. So this 7 will be the actual answer of 15 float divided by 2. So if we have 15 float divided by 2, we can simply find the answer by finding out how many times this denominator divides numerator completely. How many times 2 divides 15 completely? 7 times, right? So the value will be 7. If you take 15 float divided by 4, how many times 4 divides 15 completely? 3 times, right? So this value will be 3. So in this way, we can easily find the value of float division when we have both numerator and denominator as integers. But this shortcut might be a bit confusing when we have negative numbers or floating point numbers. In such scenarios, just break it down step by step and find the right answer. So I have added all those examples here. Now let's run this program. Let me expand this a bit. So yeah, this is the output. As you can see, we got the same outputs as we discussed. And you can notice that in these last two examples, we have at least one of the operands as float, right? So we get the floating point result. Till now we discussed the first 5 arithmetic operators, and in the next video let's discuss modulus and exponent operator. And also we are going to discuss about something called augmented assignment operators. Let's meet in the next video.